The objective of this lesson is to find missing sides or angles in triangles, or to find missing ratios given other trig ratios using what are called identities. Now, an identity is a true statement on a given domain. Now, we can already start to see some true statements coming out in these ratios that we've set up. Notice that these ratios, if you look at sine related to cosecant, they're reciprocals. Now that's helpful because we have a sine key on our calculator, but we don't have a cosecant key. So what we'll do is when we need to find cosecant of theta, we're going to use the sine key and just take its reciprocal. And so we have 1 over sine of theta is going to equal that cosecant. Well, the same is true for cosine and secant. If you want to find secant of theta, you're going to do the reciprocal of cosine of theta. And if you want to find cotangent, you can do the reciprocal of tangent. So these reciprocal identities will help us to find information when we're looking for these trig functions. We can use the reciprocals of the other ones. Next, we want to relate functions that have a co in front of them into the function that doesn't. For instance, sine and cosine, tangent and cotangent, secant and cosecant. Now, let's first of all identify if we have a triangle here. Let's use 60 degrees as one of our angles in the right triangle. So right triangle with the angle down here. If this is 60 degrees up here, then this other angle, we'd find it by taking 180 minus the 90 minus the 60, and we get this to be 30 degrees. Well, it makes sense because if 180 degrees is what a triangle adds up to, if you've got 90 degrees taken up by the right angle, the other two have to add up to 90. Well, just a reminder, what that means is two angles that add up to be 90 degrees are called complementary angles. So let's state that over here. Complementary angles add up to 90 degrees. Now, the co in complementary is where we get the cosine and cotangent and cosecant. It relates those together. Let's take a look at how that works. So if you look at this triangle and I relate it to 60 degrees, sine of 60 is going to be the opposite side over the hypotenuse. Now if you look at those two sides, what are their relationship to the complementary angle to 60 degrees? Well, 30 degrees here, it has the hypotenuse and it also has the adjacent side. Adjacent to 30 degrees and the hypotenuse would be cosine, where we'd have adjacent over hypotenuse. So what we can state is that if you've got sine of 60, the cosine of 30 degrees uses the same sides to get it. So cosine or sine of 60, opposite over adjacent over hypotenuse, is the same as cosine of 30 because it uses those same two sides. So how we'll write that out is we'll write that sine of theta is equal to cosine of 90 degrees minus theta. You can subtract theta from 90 degrees to get the angle. 90 minus 60 gives you the cosine angle. It works also with tangent of theta and its cofunction, cotangent. You also have the complementary angle that you take of cotangent, and the same works with secant. Secant of theta is equal to cosecant of 90 degrees minus theta. Okay, let's look at this example to kind of illustrate that. For this one, we'll go ahead and draw a triangle here with 72 degrees. So if I draw a triangle out this way, and I've got 72 degrees up here, and this is a right angle. Notice that tangent is going to be the opposite side over the adjacent side. Well, if we find the complementary angle to 72, 90 minus 72 is 18 degrees. Notice that the adjacent side over the opposite is the cotangent. So the tangent of 72, opposite over adjacent, is the same thing as the cotangent of its complementary angle because that has the adjacent over the opposite. So this tells us that these cofunction identities, these are, if you know one of them, you can find the other angle using this identity as a true statement. Okay, so we'll put 18 degrees here. 90 minus the 72 gives you 18. Now, let's go ahead and use this to solve problems. So to solve problems, we usually use this information. We're reminded to use the Pythagorean theorem, which is that a squared plus b squared is equal to c squared, where c is the hypotenuse of the triangle. We also remember that the sum of the angles of a triangle equals 180 degrees. We'll use that fact at times to find an angle or two. And then if you want to get angles from sides, you use the inverse sine, inverse cosine on your calculator. If you notice that those are right above the sine, cosine, and tangent, we're going to use those buttons to find the inverse, use the inverse buttons to find the angle measures. We'll use our trig ratios that we used up above and also the trig identities. So if you look up here, these are the trig ratios and here are the identities we can use. Let's go ahead and use those to solve some problems. So let's look at this first one. The first thing I would recommend that you do in a problem like this is that you draw a diagram. You don't have to, but it's helpful to draw a triangle to help you with doing the problem. So to do this, I'm just going to draw a triangle. And I'm going to say if this is my theta up here, and then this is my right angle here, I'm going to say that cosine is going to be the adjacent side over the hypotenuse. So let's go ahead and find, how do you find the missing side? Well, let's go ahead and find the missing side by using our Pythagorean theorem. We're going to say that 7 squared plus x squared, which we don't know this side, is equal to 25 squared. And so we're going to have x squared equal to, we're going to do 25 squared, which is 625, minus 49, which is 7 squared. So x squared is going to equal, when we subtract those, that's going to be equal to 576. Let's go ahead and do that on a calculator just to show. So we've got 625 minus the 49, and we get 576. To get x, we're going to go ahead and take the square root of that. So second square root. We don't need the negative, we just need the positive because it's the side of a triangle. And so x equals 24. So we get our missing side here. I'm going to write it, it's going to be kind of small here, but this is going to equal 24 here. Okay? So I now have a triangle, or you might remember your Pythagorean triples. Those of you who remember those would come in handy. 7, 24, 25 could be used here. Now, we're going to find the other 5 trig functions. I'm going to just list out everything here. We want to know sine of theta, cosine of theta we've got is 7 over 25, and tangent of theta. And then we want to also find, and I'm going to list them with their reciprocals right across. And then we're going to find these missing 5. Okay, we've got the 1 ratio, find the other ones. Well, first of all, we immediately can use our reciprocal identities to say if cosine is 7 over 25, then we're going to find that secant is 25 over 7. Okay, we can get that one immediately. Now we can go to our triangle here and say if find sine theta, well, sine theta is opposite, which is 24 over the hypotenuse, which is 25. So 24 over 25. And the reciprocal for cosecant is 25 over 24. There's another use of an identity. And then lastly, to get tangent, here's theta. I go with the opposite side, which is 24. I go with the adjacent side, which is next to it, which is 7. So I'm going to go with tangent is 24 over 7. And so cotangent is the reciprocal, 7 over 24. So notice I can find all of the missing trig functions by drawing a diagram, using Pythagorean theorem to find the missing side, and then go ahead and use my trig ratios and the reciprocal identities to get those values. All right, let's do a problem here which is called solving a triangle. It gives us certain information. It says draw a triangle ABC. So I'll draw a triangle ABC. Now we've been using theta on the inside as an angle. Another thing we sometimes do is we use letters on the outside to label angles. C in this case is the right angle, so I'll make sure that's down there. And then it says that A is equal to 20 and B is equal to 15. When we give the little letters, they're opposite their angles. So this one is opposite angle A, and this one is opposite angle B. So that's when it gives those little letters, you just go straight opposite it to give that value. Now we're going to find the missing side and the angles on this. We don't know A or B, we know C. So first of all, let's find the missing side. Well, we'll use Pythagorean theorem. So we're going to go with 15 squared plus 20 squared. I'm going to call this C because that's opposite angle C is equal to C squared. So let's do our calculations here. 15 squared plus 20 squared. So 15 squared plus 20 squared. And that gives me 625 is equal to C squared. Now you take the square root of both sides, square root of 625. So second square root of 625, and we get a 25. So our missing side then is 25. So that's the first thing we found. So we'll list this over to the side. Angle C is equal to 25. Now all we're missing, we have angle C, the side C is 25. We've got angle C is 90 degrees, but we don't have angle, the measure of angle A or the measure of angle B. Let's calculate what those are. Now the first thing is you got to pick one of them and then use that inverse trig function. That's where we put here using the inverse trig function to calculate it. So what I'm going to do is I'm going to use the fact that A here, its opposite side is 20, its adjacent side is 15. And so what I'm going to do is say that tangent of A is equal to 20 over 15. Well, how you calculate what the measure of A is you take the inverse tangent of 20 divided by 15. So that's where this comes in handy. Let's do that on the calculator. So we're going to go second tangent here, inverse tangent of 20 divided by 15. Now, got to make sure, one thing you need to do is make sure that you're in degrees in this case, because we're talking about degree measures for this, but later you'll learn about radians, but for now we're going to be in degrees. So in degrees, this gives me 53.13. Now, you'll be told probably what to round to. Here I'm going to round to the nearest degree, and so I'm going to make this a 53 degree angle. So this is approximately 53 degrees. So that's my measure of angle A. Now I've got to find out what the measure of angle B is. Well, you could do the same thing for a measure of angle B by using an inverse trig function, but now we know two angles. To find the third, all you have to do is to subtract them from 180. So I'm going to take my 180, I'm going to subtract 90, the given right angle, and then I'm going to subtract the 53 I just calculated for the measure of angle A, and I get 37 degrees. So this one's 37, and I got this by taking 180 minus 90 minus 53 degrees to get that angle. So we now have all the missing parts of a triangle. It's called solving a triangle. You can use the information that we have to get that. Our last problem here is if you got cosecant of 51 degrees, you want to find secant. Let's go ahead and use our cofunction identity. These two angles have to be equal to, add up to 90 degrees. So there's two ways to do it. You can either say 51 degrees plus alpha, that's the Greek letter alpha, is equal to 90, or more likely you'll just say that alpha is equal to 90 degrees minus the 51. So this is that identity we used right here, where if you take 90 minus it, you get that value. So 90 minus 51 degrees is going to be equal to 39 degrees for it. All right, and I'll circle that for it. We'll circle these as our answers to this problem. So what we've done is we've used identities, which are true statements on a given domain, and we've used our trig ratios to find missing information in triangles, to find missing trig ratios or missing angles, and if we use that information, we can solve problems.